Okay, if you've ever written even a single line of code, you know this feeling. Everything looks perfect, you hit run, and then, bam, it all falls apart. Today, we're talking about how to actually master those moments. We're diving deep into error handling, what I like to call your code's ultimate safety net.
All right, let me ask you something. Have you ever been there? Your program is running along just fine, doing its thing, and then the next second, it's just gone. Poof. No warning, no polite goodbye, just silence.
And what are you left with? Usually something that looks like this: a terrifying wall of red text. A traceback that honestly looks like an alien language at first. This thing right here, this zero division error, it's not just nonsense. It's your program's last gasp. It's a clue telling you exactly what went wrong. And that clue is what brings us to our first big idea. We're going to completely reframe how you think about these crashes. They're not just failures, they're not random acts of chaos. They are predictable, understandable events that we can absolutely learn to manage.
So first things first, not all errors are created equal. You've got two main flavors. On one hand, you have syntax errors. These are basically grammar mistakes. You forgot a colon or a parenthesis. Python looks at this and just says, nope, I don't even understand this, and it won't even try to run. But on the other hand, you have runtime errors, or what we call exceptions, and this is our focus today. The grammar is perfect, the code is valid, but while it's running, it hits an impossible situation.
So let's properly introduce the star of the show, the exception. It's time to stop thinking of it as the scary thing that breaks your code and start seeing it for what it really is. It's Python's built-in alert system. It's a messenger trying to tell you, hey, you down there, something unexpected just happened. And yeah, here's the formal definition. It's an event that disrupts the normal flow. But let's make that real. Think of your code as a river, flowing along smoothly. An exception is like a giant dam that just appeared out of nowhere. Wham! The flow stops cold. Our job isn't to prevent dams, it's to build a spillway so the river can keep on moving. And that spillway, that safety net, well, that's exactly what we're talking about next. It's called the try except block. And this little tool is what puts you, the programmer, back in control of the chaos. This right here, this is the whole game. It's a massive shift in thinking. Instead of your program just hitting that dam and crashing to a halt, what if you could anticipate it? What if you could build something to catch the error, handle it gracefully, and let the rest of your program continue on its merry way? And the logic is actually beautifully simple. You're basically saying to Python, hey, I want you to try running this next piece of code. Full disclosure, I know it might be a little risky. And then you give it a plan B. If and only if an exception happens in there, don't panic, don't crash, just jump down to this except block and run this other code instead. And just like that, you've caught the error. Now, catching any old error is a fantastic start, but we can get so much more sophisticated. We can get specific. This is where we level up from using a giant, clumsy net to using a precision tool. It is all about working smarter, not harder. I mean, just think about it for a second. Let's say you're asking a user for their age. Well, what if they type 20 instead of the number 20? Or what if your code is supposed to open a file, but that file doesn't actually exist? These are totally different problems, right? They deserve totally different responses. And these are some of the usual suspects you'll run into. There's value error. That's when you get the wrong type of data, like text when you wanted a number. We've already met our old friend zero division error. And, well, file not found error is pretty self-explanatory. Each one is a specific signal for a very specific problem. And here's where things get really, really cool. You can stack them. You can have one try block and then follow it up with except value error, then except file not found error, and on and on. You're literally building a sophisticated custom response system for every single thing that could go wrong. And just a quick pro tip for you, it gets even better. There are these other optional pieces, else and finally. The else block runs only if the try block was successful. And finally runs no matter what happens, error or not. It gives you an incredible amount of control. Okay, so we've been deep in the weeds with try and except. But let's pull back for a second. Why does any of this really matter? Because mastering this skill, right here, is what separates someone who just writes code from someone who builds real, professional software. See, this is about so much more than just fixing bugs. It's about building programs that are robust, programs that don't just fall over at the slightest surprise. It's about creating a way better experience for your users, giving them a helpful message instead of a screen full of red text.
Honestly, it's the hallmark of writing professional-grade code.
I absolutely love this quote because it just hits the nail on the head. Any program can work when everything goes perfectly. But a truly great program is one that keeps on chugging or at least fails gracefully when the world is messy and imperfect. That's what robustness is all about.
At the end of the day, learning to control crashes gives you the power to build with confidence. Now you can create programs that can handle bad user input or missing network connections or anything else the messy, real world throws at them. So the only real question left is, with this new power, what are you going to build first?